So I am Dr. Suresh from School of Mechanical Engineering. So today we will see balancing of rotating mass. So this topic comes under the Unit 2 in the course Dynamics of Machine. Course code is BTME3008. So we already know about these two terms, that is centrifugal force and equilibrium. So centrifugal force is nothing but when body moves in a circular motions, the body will be experiencing two types of forces. One force acting outside, another force acting towards the center point of rotation of the particular body. The force which is acting outside, that force is called as a centrifugal force. The force is acting towards the center of rotation, that force is called as a centripetal force. So this is the two type of forces which is acting on the body when the body moves in a circular motion, circular revolution with respect to the center point. One is centrifugal force, always acts outside the body when the body is moving in the circular motions. Then second one is equilibrium. So we know everyone about this, what is meaning for equilibrium. So equilibrium is nothing but when the body is in the equilibrium state, the net force acting on the body should be zero. So the high-speed engine and other machines is equipped with the rotating and reciprocating parts. So these rotating and reciprocating parts are to be balanced as far as possible. If the parts are not properly balanced, the dynamic forces are set up. So these forces not only increases the load on the bearings and stresses in various members, but also produce unpleasant and very dangerous vibrations. So because of this unbalanced forces, this will create maximum vibrations in the IC engine. The balancing of unbalanced forces caused by the rotating masses. So this topic we are going to discuss in detail in this lecture. Whenever a certain mass is attached to the rotating shaft, it exerts some centrifugal force, whose effect is to bend the shaft and to produce vibration in it. In order to prevent the effect of centrifugal force, another force is attached to the opposite side of the shaft at such a position so as to balance the effect of centrifugal force of the first mass. This is done in such a way that the centrifugal force of both the mass are made to be equal and opposite. The process of providing the second mass in order to counteract the effect of the first mass is called as balancing of rotating mass. For example, so this line is indicating this axis of rotation, axis of rotations. In the axis of rotation, so there is another one mass is there. That mass is m2, which is denoted by m2, which is at a distance of r2 from the axis of rotations. So when only this m2 mass is attached to the rotating shaft, when this mass is rotating, then outward force will be exerted from the m2 mass. So that force is called as a centrifugal force. So this centrifugal force create the bending action on the shaft. So in order to counteract that, so we are adding that another mass, that is disturbing mass in the same plane of this m2 mass. So the disturbing mass also will produce the centrifugal force. So that centrifugal force which will be equal and opposite to the balancing mass. So the system is in the balancing state. So this is the process of providing the second mass, that is the disturbing mass, in order to counteract the effect of centrifugal force of the first mass, that is balancing mass. So this process is called as balancing of rotating masses. The different cases of balancing of rotating mass. The following are the different cases of balancing of rotating mass. First one is balancing of single mass rotating mass by a single mass rotating in the same plane. Second one is balancing of single rotating mass by two mass rotating in the different planes. Third one is balancing of different masses rotating in the same plane. Fourth case is the balancing of different mass rotating in the different plane. So these are the different cases of balancing of rotating mass. Balancing of single rotating mass by a single mass rotating in the same plane. Considering a disturbing mass m1 attached to the shaft rotating at omega radian per second. So let disturbing mass is the mass which is attached to the shaft, which is at a radius r1 from the axis of rotations. Then in order to balance this disturbing mass, another mass is added in the same plane. That magnitude of the mass is m2, which is located at a distance r2 from the axis of rotation. The centrifugal force exerted by the mass 1 on the shaft equal to Fc1 equal to m1 omega square r1. So this is the centrifugal force produced by the disturbing mass m1. That is Fc1 equal to m1 omega square r1. This centrifugal force produced by the first mass, which will be acting away from the center of rotations, which tends to bend the shaft axis. In order to counteract the effect of the centrifugal force produced by the mass m1, a balancing mass m2 may be attached in the same plane of rotation as that of a disturbing mass m1 in such a way that the centrifugal force due to two masses are equal and opposite. So m1 is the disturbing mass. Because of this m1, a centrifugal force Fc1 will be created, which is acting radially outside from the shaft axis. In order to counteract this centrifugal force produced by the disturbing mass, another mass is attached in the same plane. The magnitude of that mass is m2, which is at a distance of r2 from the axis of rotation. The second mass also will produce a centrifugal force, that is Fc2. The centrifugal force produced by the mass m2 equal to Fc2 equal to m2 omega square r2. So where m2 is the mass of the balancing mass, omega is the angular velocity of the shaft, r2 is the radius of location of the mass 2. So this centrifugal force produced by these two masses m1 and m2 are equal and opposite. So we can write the equation as Fc1 equal to Fc2, that is m1 omega square r1, which will be equal to m2 omega square r2. The angular velocity remains constant for these two cases, so omega square will get cancel each other. Then m1 r1 equal to m2 r2. So this is the relation. So for the balancing of single mass rotating in the same plane by providing the another single mass in the same plane. Balancing of single rotating mass by two mass rotated in different planes. In the previous case, that by introducing a single balancing mass in the same plane of rotation as that of disturbing mass, the centrifugal force are balanced. In other words, the two forces are equal in magnitude and opposite in direction, but this type of arrangement for balancing gives rise to couple, which tends to rock the shaft in its bearing. Therefore, not to put the system in complete balance, the two balancing masses are placed in two different planes parallel to the plane of rotation of the disturbing mass. So here, this is the one disturbing mass. In order to balance this disturbing mass m, so two balancing masses are added, one in the plane, that is mp, that the magnitude of the mass is m2. Another mass is added in the plane LQ, that is the magnitude of the mass is m1. The centrifugal force produced by the disturbing mass m will be get balanced by the centrifugal force produced by the m1 as well as centrifugal force produced by the m2. So this type of case is called as balancing of single rotating mass by two masses rotating in different planes. The complete balance of rotating masses, the following two conditions of equilibrium need to be satisfied. The net dynamic force acting on the shaft is equal to 0. In other words, the center of masses of the system must lie on the axis of rotation. This condition for static balancing. So for the system to be in the static balancing means the net dynamic force acting on the shaft is equal to 0, and other words, the center of masses of the system must lie on the axis of rotation. The second one is the net coupled due to dynamic force acting on the shaft is equal to 0. In other words, the algebraic sum of the moments about any point the plane must be 0. The conditions 1 and together will give to leads to dynamic balancing. The balancing of single rotating mass by providing the two masses in different planes. In these cases, the two possibility may arise while attaching the two balancing masses. Case 1. The plane of disturbing mass may be in between the planes of two balancing masses. And second one is the plane of disturbing mass may lie on the left or right of the two planes containing the balancing mass. For example, case number 1, the plane of disturbing mass may be in between the planes of two balancing masses. For example, this mass m, that is a hatched portion, this is a disturbing mass which is lie in between the two balancing mass, that is m1 and m2. So this is the one way of arranging the balancing mass can be kept either side of the disturbing mass. The second case is the plane of disturbing mass may lie on the left or right of the two planes containing the balancing mass. So let plane L, the balancing mass is m1, and the plane M, the balancing mass is m2. These two balancing masses are kept either on the right side or left side of the disturbing mass. So this is the case 2 for balancing of single mass by providing the two masses in two different planes. The plane of disturbing mass may be in between the planes of two balancing mass. Let L1 is the distance between the planes A and L, and L2 is the distance between the plane A and M. Then L is the distance between the plane L and M. The centrifugal force exerted by the mass M in the plane A, that is the centrifugal force of disturbing mass Fc equal to m omega square r. The centrifugal force exerted by mass m1, that is a balancing mass in plane L, Fc1 equal to m1 omega square r1. The centrifugal force exerted by mass m2 in the plane M, Fc2 equal to m2 omega square r2. Since the net force acting on the shaft must be equal to 0, therefore the centrifugal force produced by the disturbing mass, which will be equal to the sum of centrifugal force produced by the balancing masses, that is Fc equal to Fc1 plus Fc2. Then after substituting the value for Fc1, that is m1 omega square r1, for Fc2 m2 omega square r2, which will be equal to the centrifugal force m omega square r. Since the omega value is constant for all masses, so it will get cancel each other, and finally the equation will be reduced in this form: mr equal to m1 r1 plus m2 r2. So this equation represents a static equilibrium condition. Now, in order to find the magnitude of balancing force in plane L, take moment about P. Take moment about P. So, if you take moment with respect to point P, that is centrifugal force produced in the plane L, that is Fc1 into L, then moment for the disturbing mass, for that centrifugal force is Fc into L2. The equation will be becomes like this: Fc1 L equal to Fc L2. Then finally, after substituting that centrifugal force value, then neglecting the omega, so because angular velocity is same for all the masses, so we neglect the omega value. This equation will be reduced in this form: m1r1l equal to mrl2. Similarly, in order to find the balancing mass in plane m, we have to take moment with respect to point q. The centrifugal force in the plane M is, that is Fc2 into L. Similarly, if you take moment for the disturbing mass, that is Fc into L, then finally this equation can be written as Fc2L equal to Fc into L1. Once after substituting the centrifugal force value, the equation is becomes m2r2l equal to mrl1. For dynamic equilibrium, all three equations need to be satisfied. So for case 2, when the plane of disturbing mass lies on one end of the plane of the balancing mass. In this case, the mass m lies in the plane A and the balancing mass lie in the planes L and m. So here this mass m is the disturbing mass which is lie on the left hand side of the balancing masses, that is m1 and m2. The following condition must be satisfied in order to balance the system. So that is Fc1 equal to Fc plus Fc2, the centrifugal force produced by the balancing mass m1, which will be equal to the sum of centrifugal force produced by the disturbing mass and the centrifugal force produced by the balancing mass m2. So the following condition need to be satisfied for balancing the given system. Then after substituting the values of centrifugal force, the equation becomes m1r1 equal to mr plus m2r2. So this equation represents the static equilibrium condition. So now to find the balancing force in plane L, take moment about point P. So therefore Fc1 L equal to Fcl2, that is we have to take moment with respect to point P. So this is a point P. So with respect to this point we have to take the moment of forces. So here one force is there. This force is produced due to the this disturbing mass, that is Fc into L2, that is the moment. Similarly, the centrifugal force is produced in the balancing mass m1, that is Fc1. The moment produced due to this balancing mass is Fc1 into L. This equation will be written like this: Fc1L equal to Fc into L2. Then after substituting the centrifugal force values, the equation becomes m1r1L equal to mrl2. Similarly, to find the balancing force in the plane M, take moments about Q. So this is not to find out the balancing force in plane M. So we have to take moment with respect to point Q. This is a point Q. So here one force is centrifugal force is there, which is produced due to the this disturbing force. Then another force is here, that force which is produced due to the balancing mass m2. So we have to take moment with respect to the point q. Therefore the moment of force is for this disturbing mass is, that is Fc into L1. Another moment of force for the balancing mass m2 is Fc2 into L. Then equation can be written like this: Fc2L equal to Fc into L1. Then after substituting the centrifugal force values, then equation becomes M2R2L equal to MRL1. For dynamic equilibrium condition, all three equations need to be satisfied. So these are the questions related to the today's lecture topic. First one is balancing. What is balancing? How the rotating masses are balanced. Then second questions can be, so what is the meaning for static and dynamic balancing. Then third question is balancing of rotating masses. Then fourth one is balancing of single rotating mass by single mass rotating in the same plane. Then fifth question is balancing of single rotating mass by two masses rotating in the different planes. So these are the questions. So we can familiar once after go through in this video. So these are the textbook and reference book for the today's topic. So textbook SS Ratan is used for reference book RS Kurmi and Gupta, A. Ghosh, then Thomas Williams. So this book can be referred for this today's lecture topic. So thank you for watching the sessions. So we'll see this continuation of balancing of rotating mass in the next forthcoming PPT.